Hello, my name is Jeff Grant, and today I'll be performing scalpel blade sharpness tests using this scalpel blade sharpness testing machine. The way this machine is designed, you load a scalpel blade into this handle, which is free floating. The blade rides against polyolefin test media material, which is loaded onto the steel shaft. As the blade cuts through the test media, it makes electrical contact, and it records the number of revolutions it took for the blade to cut through the material. The lower the number, the sharper the blade; the higher the number, the duller the blade. I'm going to relocate the camera now to give you a close-up view of the blade as it's cutting through the material. We're going to look at the Swan Morton blade, the BD blade, and the Diamantine blade by JDI. Here now is a close-up view of the test machine. Here's the digital counter. The light above it is an indication that the blade has cut through the test media. We have the blade loaded into the handle, riding against the test media. That black line on the media indicates the 0 position. As we start the test, you'll see the line turn around as the shaft is spinning. The electrical wire connecting the blade to the indicator, and other control. The first blade we'll be testing is the BP carbon steel ribback blade size 10. Open the pack, remove the old blade from the test rig, load in the new blade. And then I'm going to advance the carriage to a new section of media, center the spindle, gently place the blade on the test media, set the counter to 0, and start the test. Now you can see the counter recording the number of revolutions as the blade cuts on the material. We've already reached 20 revolutions and the blade still has been unable to cut through the test media. This test material, by the way, is commonly used as a heat shrink wrap material on electrical wires. So it's a very robust material, difficult to cut through, it's abrasive resistant, and as you can see, the BD blade is having a very difficult time cutting through the test media. If the blade doesn't cut through, I was going to say by 60 turns, then we need to discontinue the test. But here we are at 59 revolutions and the blade finally cuts through the material. So what we'll do now is I'll open a Diamantine blade. This blade has a coated edge, which you may not be able to see at this level, but a bright gold color, which is the zirconium nitride material, which is a ceramic material, very hard, very sharp, and wear resistant. So I'll unload the BD blade. Load in the Diamantine blade, advance the carriage to a new section of media, gently place the blade onto the test media, and what I'll do here is rotate to the top position, the black line, rest the blade on the media, 0 the counter, and start the test. And as you can see, it took 3 revolutions for the Diamantine blade to cut through the test media. Now I'm going to test a size 15 Swan Morton blade on the test system. So load that blade into the handle. Advance the carriage to a new section of media. Gently rest the blade on the spindle, 0 the counter, and away we go. This blade took about 5 revolutions to cut through the test media, actually pretty good performance for the Swan Morton blade. Now I'm going to test a size 15 Diamantine blade. Put it onto the test handle. Get our media to the top center. Advance to a new section of material. Gently place it on the media. Zero the counter. Start the test. And here we had just over 1 revolution to cut through the media. So once again, the Diamantine blade significantly outperforming both the BD and the Swan Morton blade on both the size 10 and the size 15. These results are typical of all the size ranges 10, 11, 15, etc. Here now I'm going to do an extreme close-up. This time I'm going to go back to the size 10 Bard Parker blade. Take it out of the package here. Load it onto the test rig. Advance to a fresh section of media. Put the spindle to top dead center. I'm going to put the counter to 0. That's out of the field of view, but you will be able to count along with the with that mark on the media, and I will let you know what the final results are here. So here we go, starting the test. We're up to 10 now. Just over 20. 30. 40 revolutions now. And once again, if we get up to about 60, I'll discontinue the test because there probably is not much of a chance of the blade cutting through the material. It's just riding on top of the material, skidding along because it's not sharp enough to cut through. Well, there we have it, 62 revolutions, very consistent with that first testing we did where we got a 59. So now I'll remove this blade, put the Diamantine blade in, advance the carriage to get to a new section of media, put it to top dead center, gently place the blade onto the test media, zero the counter, and start the test. And the test is complete at 3 revolutions. Once again, the same sort of ratio we saw on the last test we did on the Bard Parker versus the Diamantine blade.